Hello, welcome to the video. In this lesson, we're going to be looking at section 2.1, where we're going to be looking at transformations of quadratic functions. So we know that anytime we have a quadratic function, we are going to be looking at a parabola. All right, like our parabola are either our right side up U shape or upside down U shape values. Okay. Some of these concepts we looked earlier on in our class. Some of it will be review, some of it will be new material. Um, so we'll take a look at these and be able to answer the questions. Hopefully, some of these different general equations and general concepts will be reviewed for you. So the first thing we're going to look at is when we are transforming a quadratic function, it's either we're going to shift it up or down or left or right. If we're doing it up or down, we're looking at a vertical translation. Vertical translation, that means we have a value of k. All right, k is always represented as is in the function. So if it's plus, it means it's moving upward. If it's minus, it means it's moving downward. When you have a left or right translation, we have a horizontal translation. That means we have a value of h involved, right? H is always represented as the opposite of how it appears because it's minus h. So when it's minus h, it's going to be positive. When it's plus h, it's going to be negative. So plus means going to the positive h means it's going to the right. Negative h means it's going to the left. So here they're asking you to describe the transformation uh, in these particular functions. So if I look at the first one, I have x minus 3. That means that's telling me that h is 3. Because h is 3, the graph is being moved 3 units to the right. Here we have x is minus 2, and then we have the minus 2 on the outside. That means that h is 2, but k is negative 2. So that means there's two parts of this transformation for number 2. That means that you moved the graph 2 units to the right and 2 units down. Looking at number 3, in this case, it's x plus 5, so that means that h is negative 5 and k is positive 1. So that means that it moved in 2 spots, so it moved 5 units to the left and 1 unit up. Anytime our graph is reflected over the x-axis, it just means we have our upside down U shape. Anytime that our graph is reflected over the y-axis, in this particular instance, it appears symmetrical. So we talked quite a bit about vertical stretches and vertical shrinks when we first were introduced into parabolas. We got introduced to horizontal stretch and shrinks in chapter 1. And basically, it's the same concept. Your value of A is placed on the outside of the function for stretches and shrinks. Your value of A is placed in the inside of X when it's a horizontal stretch and shrink. Remember, when you're dealing with a horizontal stretch and shrink, you are writing it as the reciprocal of the stretch, the respected stretch or shrink. Like I said, so if it's a factor of 1/2, you write it as 2. If it is a factor of 3, you write it in as 1/3 if it's a horizontal stretch or shrink. So keep that in mind. So here they're asking you to describe the transformation from the graph. So if you look at here, my value of A is actually a negative 1/2. So the negative value means that it reflects over the x-axis. And the 1/2 means that it is a vertical shrink of 1/2. For B, in this particular instance, since 2 is inside the value of x, this means I have a horizontal, in this case, remember, it's the reciprocal. It's a shrink of 1/2. And because of the +1, the graph got moved 1 unit up. So there's 2 things happening there, just like there was 2 things happening here. So there's 1, 2, 1, 2. So same thing here, talking about transformations. This one here has a horizontal stretch of a factor of 3, and there's no movement there. Looking at 5, this one here has a vertical stretch because it's on the outside of a factor of 3. And then H is 1, so it moved 1 unit to the right. And that was it for that one. For 6, because it's negative, it reflects over the x-axis. With H being -3, it moved to the left 3 units. And then finally with K being 2, it moved up 2 units. Okay, so these final questions, they are going to be giving us some specific transformations, whether it's stretch, shrinks, translations, and stuff like that, and then are going to give us a specific function, and then we have to rewrite the function. So for this one, they're giving us the function of x squared. They're telling us we have a vertical stretch of a factor of 2, and the translation is 3 units down. So which they're telling me, oh, and it's also reflects over the x-axis. So not only is that tells me that the value of A is going to be -2, and I have a value of K, which is -3. So my general equation, so here is I got this f of x is equal to x squared. That means that I'm going to use g of x in this case is what they want me to do. So g of x is going to be equal to -2x squared minus 3. All right, they want you to identify the vertex. The vertex in this particular instance is going to be 0, -3. For this particular graph, it's telling us to write a rule for g. They want us to use the function x squared minus 5x, and they're telling us that it translates 3 units to the right and 2 units up. So that means we're going to be using h is 3 and k is 2 for this particular instance. So for this function, f, what you're going to do, because h is 3 and k is 2, you're going to look at it as x minus 3 plus 2. So what you're going to do with that is this. So wherever there's a value of x, you are going to replace that with x minus 3. So here it's x is being squared, so g of x is going to be equal to x minus 3 quantity squared, because that's where this comes in, minus 5 times it by, now it's x, now you're going to replace x with x minus 3, and then you have this leftover of plus 2. So this is how you write out the function. So I'm going to FOIL this out. So this is going to turn into x squared minus 6x plus 9. I'm going to distribute this negative 5, so it's negative 5x plus 15 plus 2. Combining like terms, my value for g of x in this particular instance is x squared minus 11x plus 26. Okay. The last thing that it says here is that it reflects over the y-axis. So anytime that it reflects over the y-axis, what you are actually going to be doing is this, is you're going to put a negative with respect to x, and then finally solve. So since there's a negative inside this parenthesis, negative 1 squared is still going to be positive 1. So g of x is still going to be positive x squared, but this negative 11 times it by negative x is now going to be positive 11x, and so now it's plus 26. So my final result is x squared plus 11x plus 26. All right, so last problem in the notes. Here we have, they're telling us we have a translation of 4 units to the left. We have a horizontal shrink of 1/3, and we're using this function. So with this, we're going to have a function where we have x, and then it's moved to the left, so it's going to be x plus 4, but it's a factor of 1/3, so 3 gets placed here. So again, same thing, wherever I see x, I get replace that with the 3x plus 4. So my g of x is going to be equal to 3x plus 4 quantity squared plus 3x plus 4. So now I'll expand 3x plus 4 and multiply it, so this turns into 9x squared plus 24x plus 16. Then I get this plus 3x plus 4. Combining like terms, I get 9x squared plus 27x plus 20. And that is being able to look at transformations of quadratic functions. I hope this helps. Until next time.